Hi, this is my glider report by Karthik Chilakapati. For the introduction, I named my glider Bewilderment, which is basically based off of how I felt most of the project. I was curious but also confused on the whole process, but it worked out in the end. So moving on to the project description, we were given a task of creating a glider with the following restrictions. Primarily made of balsa wood, travel distance of 20 feet, and must not exceed 16 by 16 inches. So, analyzing the requirements, we see that it has to be 16 by 16 inches in size, travel 20 feet, and primarily be made of balsa wood. The measures of success for each of these requirements was that my glider was 11 inches by 14.5 inches and traveled a total distance of 28 feet. So, when creating this glider, three alternatives were considered in each of these three categories of wing shape, dihedral, and adhesives. So, in wing shape, the three alternatives were a rectangular shape with a wing length of 7 inches and a root and tip chord of 3 inches, a tapered trapezoidal shape with a wing length of 7 inches, a root chord of 3 inches, and a tip chord of 2.5 inches, and an elliptical shape with a wing length of 7 inches and a root chord of 3 inches. So for category two, which considers dihedrals, three options were no dihedral, 5 degrees dihedral, which basically meant something like this, and then 5 degree anhedral, which is down. And then category three focused on adhesives, and three options were tape, superglue, and hot glue. Moving on to the pros and cons of each of these categories. For the rectangular shape, the pros were that it's easy to build. That's basically how our balsa wood came. It was just a rectangular shape, and you wouldn't have to spend much time on creating this design. But cons are it would have low lift and have unnecessary mass being on the wings. Second option was taper trapezoidal shape, which had a pros of medium to high lift and easy to build. You would just have to cut the corners of the rectangle to create the shape. And there were also not really many cons for this shape. For the elliptical shape, the pros were that this shape has like one of the highest lift generation, but also the cons are that it would be very hard to carve from the wood because you have to be very precise. And sanding the balsa wood down would possibly break the balsa wood. Category two for dihedral. First with no dihedral, pros would be that it would be easy construction. You would just paste the wings onto the side of the fuselage. But the cons are that it would not generate much lift. A 5 degree dihedral would give us high lift and more stability, but it would also increase drag. And then 5 degrees anhedral would improve maneuverability of the glider, but it would also be less stable. Category three was focusing on adhesives. Tape, its fast application. You would just stick it onto the glider and it would stick. But the cons were that the wings and all the things that you're attaching would be very unstable. Super glue pros are that it's very strong, it's fast setting, and you can easily find this tool in many like AMSs or any common superstore. But the cons is that it can drip away from the application site when applying to it, so you have to be careful when using it. Hot glue are pros are that the pros are that it's very strong and fast setting, but the cons are that you may need a hot gun machine to use this. It's not very accessible if you're outside somewhere and you just need to use a hot gun machine to glue on parts of your glider. So, evaluating these concepts, the alternatives that were chosen in the end for the final design were taper trapezoidal shape, no dihedral, and superglue. So, going through the design process, sizing, I researched and found that your fuselage has to be 75% of your wingspan, which is basically why my fuselage was 11 inches and my wingspan was 14.5. This is my initial design with rectangular shaped wings, and the wing should be placed at 20% of the fuselage length from the nose. So, this part right here would be 20% of my fuselage. This is the initial testing of this initial design. As you can tell, it didn't really go far. It went a distance of 15 feet, which is under the 20-foot requirement, and it quickly flew to the ground, meaning that it needed more lift. So, design iterations, after looking at this, I decided that the rectangular shape should be changed to a tapered trapezoidal to generate more lift, and I added an angle of attack to the wings, so basically just move them up like this. This also would help generate more lift. So this is what my final design looked like with the trapezoidal wings and the angle of attack. So the location of the center of gravity is right about there, which is at 1/4 of my root chord, and my coefficient of lift coefficient was 0.107 and drag coefficient was 0.0651. These iterations changed my performance because my glider flew a longer distance and was in the air for a longer time. This is a video of my final glider design flying. That flew a distance of about 25 feet. On test day, it flew 28. So moving on to the conclusion, in the end, this project basically helped a lot of us learn about how wingspan, wing area, fuselage length, and all the things in between, such as root chord and tip chord, are all imperative factors when considering the construction of a glider or basically any flying vehicle. So if I were to do this again, I would change the way my angle of attack was aligned on each side of the fuselage. The had it had a very trivial distance, but basically it was like slight. Each angle of attack was a little slightly off, which I feel like caused my glider to maneuver to the side instead of going straight. If I were to do this again, making that angle of attack very similar would help my glider travel in a straight manner. And these are the citations I used to research for this project. Thank you.